Turns out there's another component to the squeeze theorem. We just proved that sine of x over x is equal to 1. What about 1 minus cosine of x over x? I'm sorry, the limit, I should be specific. The limit as x approaches 0 of sine of x over x equals 1. What is the limit as x approaches 0 of 1 minus cosine over x? Well, here's the problem. If we try what we would normally try first, right, plug in 0, we get 1 minus cosine 0 over 0. Cosine of 0 is equal to 1 using the unit circle. 1 minus 1 is 0, and we get a 0 over 0, which is an indeterminate. Now, then we would try to simplify it, right, as we talked about before, using trig identities. However, there are no identities we can use for this expression, 1 minus cosine of x over x. So what do? Well, this is going to be a little proof. I wouldn't expect you to figure this out on your own. However, I will try to walk you through it in an intuitive way that you can understand. So I would say, okay, you've got 1 minus cosine, right? Looks much like it would have a conjugate, right? The conjugate of that would be 1 plus cosine. So we're going to go ahead and multiply the top and bottom by the conjugate of 1 minus cosine. Alright, so that's pretty simple. So what will happen is it'll cancel the middle terms, right? And you'll be left with something on the first and last term of FOIL. Okay, so let's go ahead and multiply the top and bottom. And then we are going to FOIL that out. So it'll just be 1 times 1 for your first term. Let's do some color coding here. So that's your f. And again, the middle terms are going to, O and I are going to cancel in the FOIL because it's the conjugate. And then your last term is going to be negative cosine times positive cosine, which gives you negative cosine squared. Okay, so you have 1 minus cosine squared. Now that is a Pythagorean identity. Since sine squared plus cosine squared equals 1, you can rearrange it to show that 1 minus cosine squared equals sine squared. Alright, so let's scroll down. And then the bottom is going to stay the same for now. So now we have f of x equals sine squared of x over x times quantity 1 plus cosine of x. And just to refresh your memory, we started with 1 minus cosine of x over x. Alright, so now what we're going to do, I want to make sure you understand this, we're going to break this sine squared into sine of x times sine of x, because that's what it means to square something. Okay, and furthermore, we're going to break this fraction down into 2 fractions. The first one's going to be sine of x over x, and then times sine of x over 1 plus cosine. So why did we do that? Well, look, this looks very familiar, doesn't it? We just showed that the limit as x approaches 0 of sine of x over x in our last video is equal to 1. And we're going to use some simple limit laws to simplify this even further using that concept. So the limit law says that we can, the limit of this function, which is the product of 2 different functions, is equal to the product of its limits. Okay, so if we find the limit of each of these and multiply those limits, it would give us the limit of this as a whole. And by the way, this is what we're trying to find the limit of our original function. Limit as x approaches 0 of 1 minus cosine over x. We've just proven that this is equal to these 2 fractions multiplied by each other. So again, we can break this apart into 2 separate limits. That's a limit law that we learned way back at the beginning of the class. But guess what? This limit we've already shown, limit as x approaches 0 of sine of x over x is equal to 1. So we can replace that, and now we just have to find this limit, which is going to be simple because we can actually just plug 0 in. Again, we're trying to prove or show what the limit as x approaches 0 of 1 minus cosine over x is. Okay, so now let's just plug in 0. Now that we've determined the first part was 1 from our previous proof. Sine of 0 is 0, cosine of 0 is 1, so we have 0 over 2, which equals 0. And now 1 times 0 is 0, and we've just proven that the limit as x approaches 0 of 1 minus cosine of x over x is equal to 0. So to sum up, the 2 components of the squeeze theorem, the first one is actually using the squeeze theorem, right? The second one we used the first one to prove, so it wasn't really squeeze theorem. But we kind of put them both under the same topic. So the first limit you need to know is the limit as x approaches 0 of sine of x over x is equal to 1. And the second limit that you need to know is the limit as x approaches 0 of 1 minus cosine of x over x equals 0. And I suppose both of them, you know, are proven using the squeeze theorem. Now, note that the first one involving sine is equal to 1, and the second one, which involves cosine, is equal to 0. They're special cases, and we're going to use these two special cases to prove limits of other trigonometric functions. If you have any other questions about this lesson, let me know.